I want to acknowledge that Tim Architevsky has played a large role in putting this talk together, so if there's any hard questions, we'll ask him. In the program, it says an industry perspective, and really what I wanted to talk to more is about the role for alternative perspectives. There was an article last week on the Trump election, which I thought would be a good way to start my talk. And basically the article was about how could everybody be so surprised by the results of the election when 46% of the people voted for him. And basically what it was saying is if you only talk to people with the same perspective as you do, then there's some confirmation bias. And so there is a role for other points of view. And what the article said was we need to actively work to understand complexity, respectfully engage people where they're at, and build the infrastructure to enable people to hear and appreciate different perspectives. And that will lead to being better informed. So, oh, even breathing heavy here. What I'm going to try and do is give a perspective on the lens that at COSIA we look through the data at. And the main thing we're interested in is, with all of the information coming out, what should companies pay attention to? And is company X producing a discernible effect, or is it a broader issue? So we really work at the interface between the regional and the site-specific data, trying to understand changes to practices to collectively or individually make improvements. And you have to be careful not to work through one lens. In 2014, we brought together a bunch of groups to look at triggers. They're working on using statistical tools to define what's normal in data, and there were lots of groups doing it different ways. We sent them a common data set and got together, asked them to apply their statistical tools to the data, and everybody got a different answer. And we spent a lot of the second part of the workshop trying to figure out, when you use that set of tools, what's the question you're asking? And so that really becomes the key. I'm going to show some different perspectives on some of the data, but we're asking different questions. It's not a new discussion. Prior to COSIA, I worked on pulp and paper issues primarily. Oh, I said no P's, pulp and paper issues primarily. And in terms of time frame, in 1997, we were about 9 years into our studies. The first round of environmental effects monitoring data came out in 1996. And I was pretty frustrated that industry would look at the same data as I did as a government scientist, and they'd have a totally different interpretation. And so I got together with a friend from Sweden who designed their national environmental effects program, and I had helped design the Canadian one. And we got together before a conference in New Zealand and actually wrote a paper on different perspectives. And I just want to read a couple sentences from the abstract. The types of ecological assessments being conducted near pulp mill discharges have changed over the past decade, largely as a result of discussion between industry, government, and academic researchers. In spite of the adjustments in the study designs, there are still some differences in perspective that affect the interpretation of studies. The differences stem largely from a justified reluctance to make process decisions or regulatory adjustments based on traditional academic hypothesis-driven evidence. The differences in perspective strongly affect the design of ongoing studies. So it's not a new discussion that I'm going to give you, but I'm going to give it anyways. I learned some major lessons in the work with pulp and paper. I had to learn, as a fish gynecologist, what the bleaching sequence was at pulp mills, what happened to black liquor, what happened to the condensates, where spills went, what the wood furnish was, how the products changed over the year, how the treatment functioned, just so that the industry people in the audience could understand the context of what I was saying in the effects I was looking at. So a better understanding of facilities and activities helps. Also, sharing data with the companies in other than this kind of a format helps. Lack of awareness of past activities and potential influences we see affecting interpretation in some studies. processes and equipment is incorrectly described, and upgraders are misplotted on maps, even on the wall in COSIA where we have a map of upgraders. So there's some bug in the data somewhere. Improving the awareness of process will help. We actually had a discussion Friday on which of these types of waters that are called OSPW are actually process affected and which ones aren't. And so I had to change it to, there's a lot of confusion, because even in our industry group there's confusion over which of these are process affected. But if you're working on depressurization water or extraction water or tailings release water, calling them all OSPW doesn't help us understand what you were working on. Different types of in situ processes, different types of upgrading processes, different types of froth treatment processes. You don't have to become an engineer, but you need to be aware of the specifics of where you're working in order to be able to give context in a way that industry will understand. I toured in my first year at COSIA. We went to more than 100 scientific presentations on oil sands. I went with one of the scientists from industry, and I asked him to summarize for our working group at the end of the year what he learned. He said he saw 100 talks saying there was a problem, and he didn't know what he should do differently because none of it was really actionable. So I'm going to try and work through a series of examples to try and show you how at COSIA we look at data, why it's important to understand how we look at it, and that it's equally important to understand how other stakeholders look at data. Not trying to say I'm right, I'm just trying to say when we look at it through different lenses, we see different things, and we need to understand what we're looking at. We look for change. I thought the presentation at lunch that said trying to come up with a definition between what's a change and what's a problem is an interesting exercise. But when we see change, we try and separate it into expected or unexpected, and stable or getting worse. I'm more concerned about unexpected change that's getting worse than expected change which is stable. Change which is stable is a question of acceptability, and change which is getting worse is a question of sustainability. And then I want to know, is it site-specific, local, or regional? And a shout out to the USGS for Dr. Barron here. The ultimate goal is a monitoring system capable of finding site-specific, local, and regional change that's unusual. So this is the real-time flow data, surface water flow in the US. Each one of the dots is a gauge that tells you in percentile whether the flow at that site compared to historical data at that site is higher than normal, lower than normal, or about what you would expect. And we can zoom in to a state level and look at finer processes, and we can actually go in here and we can see a red dot surrounded by a bunch of blue dots. And for me, that's a yellow flag. That's something unusual. So when we look at data, we tend to look for things that are unusual, things that are exceptions, things that are variability. You need lots of work to understand the regional processes and the larger scale processes, but we also want to understand what's unusual. In a program, hopefully, that's tiered and triggered to focus attention. So this data is from Inzano et al. I don't want people to get too upset when I show data with different interpretations. This is usually plotted against production and correlated with production. And when I look at that data, I want to know, why was 12 high and 13 low? Was it the amount of wind, the timing of the wind, when the snow fell, how the snow fell, how the wind blew the snow? Once you can understand what drives variability, you can start to make predictions. So when we get the data, we screen it, we try and test assumptions, try and develop triggers and look for change outside of normal, and look for context and try to integrate across studies. Our scientific ignorance can be a blessing. We have to look at fugitive emissions, deposition data, wildlife data, fish data. We can't be experts in everything, so we just treat it, oddly enough, like data, and put cold eyes on it and try and look for things that don't make sense. Jane mentioned I was going to show the same data. This is the 2014 snow data. The issue of the background or baselines is the sites out to the northwest, we don't see increases in those sites in sediment contaminants associated with upgrading. So the question really is, in the absence of oil sands development, what would we expect the snow in this area to look like? Would we expect it to look like the Wood Buffalo Park, or would we expect it to look like the sites to the west where there's no evidence of deposition? So it's an interesting discussion, and it's an academic discussion largely. You can see that the development goes about 50 kilometers. AR6 is in the center there. Shout out to Cal Duane from Canadian Natural, who actually picked site AR6 in 1996 and has borne the brunt of criticism in our meetings ever since. Why did you pick that site? And so, generically, the snow deposition goes 50 to 60 kilometers, but specifically, it's more complex. Is it one source? Is it four? Is it focus? Is it diffuse? Is it consistent? Is it predictable? Those are the things we try and tease through the data. Again, another graph from Manzano et al., which shows the rapid decline in levels as you go out from AR6. The spots I've circled are the unusual ones. So we look for the variability, the unusual, the outliers, the exceptions, and the site-specific. And we look at the data a bit differently. In this graph, it starts from the center, and it asks the question, how far does it go? We graph it the other way. This is the 2014 data. We start at the far away and say, how close do we have to get to see it? And here you can see that it's 50 to 60 kilometers. I've taken out all the high sites and all the close sites so you can see more detail in the grass. I think that's a chemist's term for all the stuff down in the bottom. If I circle the highest sites we see as we come in from outside, and I put them on Google Earth, you can see that 3 of them are on sites or adjacent to sites. 2 of them are in Fort McMurray, and 1 of them's out to the east. And so rather than plotting to AR6, we plotted it to distance to mine fence line. And it brings the data in a lot closer. You see it's somewhere between 10 and 20 kilometers it starts to go up, except for some outliers. If I plot those, there are 3 sites around Fort McMurray and the same site again out to the east. So what I'm going to do is scale in now and take it down to just the from 10 and below. And you can see we get some more detail in the grass. When I look at the outliers we see as we come in, plot those, you can see 5 of them are to the south, and there's another site out to the east. And when I look at site facilities, the ones to the south, a lot of them are adjacent to in situ facilities. I'm going to change gears here and look at the sediment data that you've seen in some of the previous talks. That's just the individual sites rather than collapsing them into close and far. It's the individual sites. Again, we try and look for what's unusual in the data. Generically, it's higher, closer to mine sites. When you look specifically, there's much more subtle context. This is going from left to right in each box. You're moving away from development. It's the reference sites that we call background as opposed to baseline, or baseline as opposed to background. Near in situ, near mines, this is the alkylated PACs, near in situ and mines, and we can see that some of the sites near in situ facilities are going up, not unlike the sites that we see at mining. When we talked with Jane about this the other week, she said the dibenzothiophenone gives a better signal, and so if we look at that, so this shows that increases near some in situ sites are similar to mine sites. So rather than distance to AR6 or to mine fence line, maybe it should be to any fence line or to infrastructure. It's more complex when you zoom in. The question's different. If we look at dibenzothiophenone, you can see the mines, which are the 3rd box over, do show more, but we do see some sites near in situ. And you can see one of the reference sites, site C, actually has a bit of squiggle coming up in it. What we learned from Jennifer's paper is that some of the lighter, the naphthalines, if we look at those, again, if you look at the reference sites, you can see more noise in some of them. One of the in situ sites is actually very high and has always been high in those compounds. And so what we try and do is tease out in the data. This is from Jamie Summers' paper last summer, dibenzothiophenone enrichment factor from where it's the surface divided by the base of the sediment core. And when you get into about 20 kilometers out, you see it going up, but we've got some sites very close that are low and some sites that are going up. And so the interest to me is what's the difference between those sites? That's the same data plotted. If we use as the enrichment factor, the oldest to the newest, or pre-development to the newest, or we just use the newest, that's just the surface dibenzothiophenone, you get different answers. And it all comes down to what question is it when you're asked when you're looking at the data. Those sites around 40 kilometers that are high on the right and not on the left must be because the baseline was also high at those sites, because when you get the fraction, it disappears. And when we look at different sites, Jennifer's recent study, the Northwest Referent Lakes, the in situ sites, if we go back pre-development, they all had different baseline signatures in them. And so the baseline and triggers can provide context in terms of trying to understand the data better. So understanding change at site-specific, local, and regional levels using standardized triggers and a tiered approach can give you testable hypotheses, logical next steps, and the focus needed to provide actionable outcomes. Understanding what drives the variability allows you to make predictions. Interpretation is affected by the question you're asking and can be affected by the approach and the assumptions used for visualizing and analyzing data, the baseline used for comparison, and the tools used for determining significance. Developing testable hypotheses for future work within a tiered framework could be improved by a structured interpretation framework, better integration across components, and improved understanding of the layout and location of facilities and activities. And this structured framework and tiered approach can evaluate consistency, variability, and relevance, and focus attention on potential areas of concern. Different perspectives and approaches applied to the same data can generate productive conversations to bring a broader understanding of the data.
Hi, Margaret Luker with Mikisew Cree First Nation. I just want to acknowledge what you said at the outset of your presentation about perspectives, and I think that's important, more of a comment than a question. One of the themes that I've heard throughout the presentations is how do we engage others? So COSIA being a good example of a forum where industry gets together to look at issues and come up with solutions and share perspectives, and where we have had forums like CIMA, the Cumulative Environmental Management Association, which was a forum for other stakeholders to be at the table discussing these issues, bringing those perspectives. Those forums no longer exist. So I just think something for us to keep in mind going forward, because it is a theme and we continue to hear it in all the presentations. There are opportunities to go beyond the forums like COSIA and engage some of the other stakeholders.
I don't disagree. I thought one of the interesting thing about Dr. Barron's talk at lunch was the issue of, on the one hand, you publish a lot of scientific papers, but on the other hand, it's having those working group with the stakeholders that's meeting quarterly and talking about data, which actually leads to achieving the outcomes and the changes that you want. And so it is unfortunate that there's not an easier way to get the messages and the discussions going on some of this data. I think that's as close as I'll come to controversy.